On July 1st, 2025, a robotic telescope sitting quietly in the mountains of Chile caught a single moving dot of light that didn't belong. It wasn't a known asteroid. It wasn't a known comet. When astronomers ran the numbers on its path, the shape of that path told them something almost nobody alive has ever gotten to witness firsthand. This object was not born in our solar system. It came from somewhere else. Some other star, somewhat her patch of the galaxy, flung out billions of years ago, and now, for the first and only time, it was passing directly through our cosmic neighborhood. They named it 3IATLAS. The 3I means it's only the third interstellar object ever confirmed in human history. And what's happened since that July morning has turned into one of the strangest, most closely watched sagas in modern astronomy. NASA telescopes tracked it. The European Space Agency's spacecraft near Mars photographed it up close. The James Webb Space Telescope pointed its infrared eye at it and found chemistry nobody expected. And a Harvard astrophysicist spent the better part of a year arguing, point by point, that its behavior doesn't add up to just a comet. So if you've clicked on this because you saw a headline claiming NASA confirmed 3IATLAS just got stranger, you're actually in the right place because that's almost exactly what happened. Not aliens landing on the White House lawn, not a signal beamed back to Earth, but something quieter and, honestly, more interesting. A growing pile of real, peer-reviewed, telescope-confirmed data that keeps refusing to behave the way a normal comet should. And scientists are still arguing about what to make of it. Over the next several minutes, I'm going to walk you through the entire story in order. Where 3IATLAS came from, what it actually is, the string of anomalies that have kept researchers up at night, the loud and controversial, it might be technology, argument that's dominated headlines, and what the mainstream scientific consensus actually says once you strip away the clickbait. By the end, you'll understand this object better than 90% of the people posting about it online. Let's get into it. Let's start with the basics, because a lot of the confusion online comes from people skipping this part. 3IATLAS was discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of survey telescopes funded by NASA specifically to scan the sky night after night looking for anything that moves against the background stars. One of its stations, in Rio Hurtado, Chile, picked up the object on July 1st, 2025. Within days, astronomers around the world pointed their own instruments at it, and pre-discovery images from earlier in the year were dug up from archives, stretching its known observation history back even further. The very first thing that made it interesting wasn't a strange substance or a weird glow, it was its orbit. Every planet, asteroid, and comet native to our solar system travels on an elliptical path, a closed loop that keeps looping the sun forever. 3I, same Atlas, is different. Its orbit is hyperbolic, meaning it's not a loop at all, it's an open curve. The object came screaming in from deep space on a trajectory so steep and so fast that the sun's gravity could never capture it. It will swing around and then it will leave, permanently, never to return. Its speed backs this up in dramatic fashion. When it was first discovered, 3IATLAS was moving at roughly 137,000 miles per hour relative to the sun, and as the sun's gravity pulled on it during its closest approach, it sped up to around 153,000 miles per hour. For comparison, that's roughly 6 times faster than the space shuttle ever flew. No object bound to our solar system moves like that unless something extreme, like a close slingshot past a planet, launched it there. 3IATLAS arrived with that speed already built in, because it spent millions or billions of years drifting through interstellar space before gravity ever touched it. This is why astronomers immediately recognized it as only the third confirmed interstellar visitor. The first was Oumuamua, spotted in 2017, a strange elongated object that tumbled through without any visible tail, sparking its own wave of speculation. The second was Comet 2I Borisov in 2019, which behaved much more like a typical comet, complete with a visible tail of gas and dust. 3IATLAS, discovered in 2025, is the third, and in several ways, the most extensively studied of the three, simply because we had more advanced telescopes ready and pointed at it by the time it arrived. Early measurements using the Hubble Space Telescope estimated the nucleus, meaning the solid icy core at its center, to be somewhere between roughly 440 meters and 5.6 kilometers across. That's a wide range, and the uncertainty exists because, from Earth, all we can really see is the glow of gas and dust around the nucleus, called the coma, which makes it hard to pin down the exact size of the solid object hiding inside it. Importantly, NASA has been clear from the very beginning on one point that some corners of the internet love to ignore. 3IATLAS was never a danger to Earth. Its closest approach to our planet was about 170 million miles away, roughly 1.8 times the distance between the Earth and the Sun. There was never a collision course, never a scenario where this thing was headed for us. Anyone telling you otherwise is not describing the real trajectory that NASA, the European Space Agency, and independent observatories all around the world have been tracking in exquisite detail since 2025. So that's the baseline. A confirmed interstellar comet moving on a one-way hyperbolic path, H, discovered in July 2025, passing through our solar system on its way back out into the galaxy forever. Nothing about that baseline is disputed by anyone. What comes next is where things get genuinely strange. To understand why scientists kept saying 3IATLAS got stranger, it helps to walk through its actual path, because at almost every stop along the way, some new instrument caught something unexpected. In the earliest observations, back in July and August of 2025, the Hubble Space Telescope had already captured a plume of dust being ejected from the side of the comet facing the sun, along with a beginning hint of a tail. That's normal comet behavior: ice warming up, turning directly to gas, and dragging dust. Particles off the surface with it. Nothing alarming yet. Then, in early October 2025, something remarkable happened purely by chance. 3IATLAS passed within about 29 million kilometers of Mars. That's an enormous distance by everyday standards, but in space terms, it put the comet within range of instruments already stationed at Mars. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter both turned their cameras and spectrometers toward it, and NASA's Mars Orbiting and Mars Surface hardware, including rovers and orbiters, captured images too. This was actually a historic moment. It marked the closest any spacecraft belonging to a space agency had ever gotten to an interstellar object, purely because of an accident of timing and geometry. By late October 2025, 3IATLAS reached perihelion, its closest approach to the Sun, on October 29th. This is typically when a comet is at its most active because solar heating is at a maximum. For a while during this period, the comet passed behind the Sun from Earth's point of view, becoming unobservable from the ground. 31st. And observers noted the comet remained visible even in modest amateur telescopes as it re-emerged into the pre-dawn sky. Around the same window in late November and early December of 2025, two X-ray telescopes, X-RISM and XMM Newton, turned their attention to 3IATLAS and detected something that had literally never been seen before: a diffuse X-ray glow surrounding the comet's nucleus. This made 3IATLAS the first interstellar comet ever observed in X-ray light. That glow is generally explained by charge exchange, a process where fast-moving particles streaming from the sun, the solar wind, collide with neutral gas boiling off the comet and steal electrons from it, producing X-ray photons in the process. It's a known phenomenon seen in some solar system comets too, but catching it happening around an interstellar visitor was a first. December 19th, 2025, brought the comet to its closest approach to Earth, at a distance of about 269 million kilometers, close enough that ground-based telescopes, Hubble and the James Webb Space Telescope, all got their best possible look. Between late November 2025 and late January 2026, an international tracking effort called the International Asteroid Warning Network ran a coordinated observation campaign, pooling data from telescopes around the globe to nail down 3IATLAS's exact trajectory and behavior. Then, in March 2026, 3IATLAS made its closest approach to Jupiter, passing at a calculated distance of roughly 53.6 million kilometers on March 16th. This flyby became its own mini-controversy, which we'll get into shortly because of just how close that number happened to land next to a very specific and mathematically significant distance tied to Jupiter's gravity. Since then, through the spring and summer of 2026, the comet has continued its outbound journey. It's now moving out past Jupiter's orbit, heading in the general direction of the constellation Pegasus, fading in brightness as it retreats from the sun's warmth. And it will never come back. Once it crosses back out past the reach of the sun's gravity, it returns to the interstellar void, carrying with it whatever secrets are locked inside its ice. So across roughly a year, 3IATLAS gave humanity a front row seat. Discovery, a surprise Mars flyby, perihelion, an unprecedented X-ray detection, a close Earth pass, and finally a calculated Jupiter encounter. That's an extraordinary amount of observational coverage for a single object that spent, quite literally, all of human history, somewhere else entirely. Here's where the just got stranger part of the story really starts, because the chemical fingerprint of 3IATLAS turned out to be unlike anything scientists had cataloged before, even from the other two known interstellar objects. First, water. NASA's Swift Ultraviolet Optical Telescope observed the comet during two separate visits in July and August of 2025, and detected the faint ultraviolet glow of hydroxyl, a molecule that forms when water vapor is broken apart by sunlight. That confirmed 3IATLAS was actively releasing water into space, essentially spraying it out as the ice sublimated under solar heating, even while the comet was still relatively far from the sun. Researchers noted this water release was happening earlier and more actively than expected for its distance, suggesting a nucleus rich in easily vaporized ices. Then came an even bigger surprise. Follow-up analysis described the water coming off 3IATLAS as chemically unusual. Compared to anything previously measured in a solar system comet, unusual enough that researchers described it as strange water never seen before in our own cosmic backyard. That's a strong claim, and it comes down to isotopic ratios, essentially the specific proportions of heavier and lighter versions of hydrogen and oxygen atoms locked inside the water molecules. Comets act like time capsules. The exact isotopic fingerprint of their ice tells you something about the temperature and chemical environment where and when that ice originally formed. A different fingerprint means a different birthplace, and 3IATLAS's water doesn't match anything born in our solar system, which honestly makes sense since it wasn't. The James Webb Space Telescope added another layer in mid-2026 when it captured the first ever direct detection of methane on an interstellar visitor. Methane is a simple molecule, but its presence and abundance relative to other gases can tell scientists a great deal about the temperature at which the comet's ice is. Originally condensed, likely in the frozen outer edges of some other star system, billions of years ago, long before that system's star had even finished forming. JWST measurements also flagged something called a deuterium excess. Deuterium is a heavier isotope of hydrogen, and comets typically carry small, well-understood amounts of it mixed into their water ice. Researchers reported that 3IATLAS showed deuterium levels dramatically higher, cited by some researchers as around 30 times higher than any comet ever measured in our own solar system. Because deuterium enrichment builds up over long stretches of time in extremely cold environments, a signature this strong hints that this ice may have formed in... If you use Signal on your iPhone because you think it's the most private messaging app there is, I need you to stop what you're doing for the next few minutes. Because in April 2026, the FBI proved that assumption wrong in a way that should genuinely worry you. And the fix involves a setting almost nobody knows exists. Buried 3 menus deep, turned on by default, quietly leaking your private conversations onto your own lock screen and into your phone's internal storage even after you think you've deleted the evidence. Here's exactly what happened, why it matters even if you don't use Signal, and the full list of hidden iPhone settings security experts say you should check right now, today, before you finish watching this video. This isn't some abstract, far-off concern reserved for whistleblowers and government officials either, and that's really the whole point of walking through this list in this much detail. The overwhelming majority of people watching this video will never be the specific target of a federal investigation, and that's genuinely good news. But the exact same technical gaps that let investigators pull data off a suspect's phone are, by definition, sitting on every single iPhone running the same software, including yours, including mine. A thief who steals your phone off a restaurant table doesn't care whether you're a suspect in anything. They just want access, and the settings that stop a federal forensic tool from doing its job are frequently the exact same settings that stop a common opportunistic thief from doing theirs. That's why this story, despite starting with a fairly narrow criminal case, is worth every ordinary person's attention. Not because you have anything to hide, but because nothing to hide was never really the right way to think about privacy in the first place. The right way to think about it is simply that your conversations, your location history, and or accounts belong to you, and you get to decide how much of that stays visible to people who were never supposed to see it. Let's start with the case that kicked all of this off. According to reporting from 404 Media in April 2026, federal investigators managed to retrieve Signal messages from a suspect's iPhone, and here's the part that should stop you cold. The Signal app itself had already been deleted from the phone by the time investigators got their hands on it. Signal is built on end-to-end encryption, the same technology that makes it, on paper, one of the most secure messaging apps available to ordinary people. The same technology journalists, lawyers, activists, and privacy-conscious users around the world rely on, specifically because it's supposed to make interception mathematically impractical. The assumption most users make, reasonably, is that once a message is read and the app is gone, there's nothing left to find. That assumption turned out to be wrong. Investigators didn't crack Signal's encryption, and this is an important distinction because it means Signal's core security promise wasn't actually broken. They didn't need to break it. Instead, they went after something far simpler, far more mundane, and far more overlooked. The iPhone's own push notification database, a quiet background system that every single app on your phone uses to show you those little banners and previews when a new message comes in. Here's how that system actually works. And understanding the mechanism is what makes this story so unsettling. When someone sends you a signal message, Apple's servers deliver a notification to your device telling it that new content has arrived. Your iPhone then has to briefly decrypt and render that message content locally so it can display the preview text on your lock screen, in Notification Center, and in the banner that pops up while you're using another app. That rendered content doesn't just vanish instantly. Remnants of it get logged into a local database that the operating system maintains specifically to manage your notification history. Under normal circumstances, this is completely invisible and harmless. It's meant to be transient, overwritten, cycled through, and eventually cleared. But as this case demonstrated, forensic extraction tools, the specialized hardware and software law enforcement, and more troublingly, certain private actors use to pull data off a locked or unlocked phone, could dig into that notification database and recover content that the app itself and the user believed was long gone. Investigators weren't able to recover messages the suspect had personally sent. Since those never generate an incoming notification on the sender's own device, only the messages other people had sent to them, but that's still a meaningful, potentially incriminating, or simply deeply private chunk of a conversation sitting somewhere it was never supposed to survive. Recoverable long after the app itself had been deleted, in what the user presumably believed was a clean, complete removal. Once this story broke, security researchers were quick to point out something important. This isn't a flaw unique to Signal, and it isn't really a flaw in the traditional sense at all. It's a structural feature of how push notifications work across essentially every messaging app on iOS, WhatsApp, Telegram, standard messages, Instagram direct messages, all of it. Whenever an app is allowed to show notification previews, the content of that notification, meaning the actual text of the message, has to be generated and briefly stored somewhere on your device so the operating system can display it to you. And that storage step is the exact point where forensic tools can potentially intervene. This means the problem isn't Signal being poorly built. It's a trade-off baked into the convenience of notifications, generally, a trade-off most users have never been told they're making. It's also worth flagging why this particular story spread as fast as it did, because Signal has built its entire brand and its entire user base around a single promise, that it's the messaging app trusted by people who genuinely need airtight privacy. Journalists protecting sources, lawyers discussing privileged cases, activists organizing under hostile governments, and millions of ordinary people who simply value not having their private conversations exposed. When a story breaks, showing that even Signal's users weren't fully protected, not because of a flaw in Signal's own code, but because of how the underlying operating system handles something as mundane as a notification, it understandably shakes confidence in the entire category of secure messaging apps. Generally, and that's exactly why understanding the actual mechanism matters so much more than just reacting to the scary headline. This wasn't Signal failing at its one job. It was a reminder that end-to-end encryption only protects a message while it's in transit and while it's being stored inside the app that's actually designed to protect it. The moment that content gets handed off to the operating system to display as a notification, it's temporarily operating under a different, less rigorous set of protections. And that handoff point is exactly where this entire story lives. So here's the actual fix, and this is the specific hidden setting this video is named after. Open Signal, go into Settings, then Notifications, then Notification Content, and you'll find a toggle most people have never touched once in their life. By default, it's usually set to show the sender's name and a full preview of the message content, right? They're on your lock screen, convenient, but leaving a trail. Change that setting to either No Content, which hides the message text but still shows you who it's from, or for maximum privacy, No Name or Content, which strips the notification down to a completely generic alert with no identifying information at all. Making this change means your notifications become slightly less convenient. You won't get that quick glance at what someone said without unlocking your phone first, but it also means there's dramatically less sensitive data sitting in that notification database in the first place, less for anyone to recover later, whether that's a hacker, a thief who's stolen your phone, a jealous partner who picks it up off the counter, or in a worst case scenario, a law enforcement investigation you never expected to be anywhere near. And because this is a structural issue with how iOS notifications work, not a Signal-specific bug, it's absolutely worth doing the same audit across every messaging app you use. Go to Settings, then Notifications, then tap through each app one at a time. WhatsApp, Telegram, standard messages, Instagram, whatever you've got installed, and look for a Show Previews option inside each app's individual notification settings. Apple actually gives you 3 choices at the system level for this across the board. Always when unlocked and never. When unlocked is a solid middle ground for most people. It means previews only show up if your phone is already unlocked when the notification arrives. So a stranger glancing at your locked phone sitting on a table, a coworker walking past your desk, or someone who's picked your pocket can't read your messages just by looking, but you still get full convenience once you're actively using your device. If you handle genuinely sensitive conversations, work communications involving confidential material, financial information, medical details, or anything you'd truly rather nobody else ever laid eyes on, never is worth seriously considering, even if it costs you a bit of everyday convenience. Now, this notification setting is the headline story, the one that earned this video its title, but it's really just one entry point into a much bigger conversation about hidden iPhone security settings that quietly exist, do real, meaningful work protecting you every single day, and that most people never think to check even once. So let's go through the rest of them properly, one at a time. Because if you're already worried enough to be watching a video with FBI warning in the title, you deserve the full, complete picture, not just one isolated setting. First, lockdown mode. This is one of Apple's most powerful, most underused security features on the entire operating system. And it was originally built for an extreme use case: journalists, human rights activists, and public figures who might be targeted by sophisticated, extremely expensive spyware, the kind of tools nation-states and well-funded private surveillance firms use to remotely compromise a phone without the owner ever clicking a single malicious link. When you turn on lockdown mode, your iPhone dramatically shrinks its attack surface across the board. Message attachments and most link previews get blocked by default, since those are common vectors for zero-click exploits. Certain complex, exploit-prone web technologies that sophisticated hackers rely on get disabled in Safari. Incoming FaceTime, calls from numbers you haven't called before, get blocked automatically. Wired connections to accessories and computers get restricted unless your phone is unlocked at the exact moment of the connection attempt. Shared albums and invitations get restricted too. It sounds extreme, and for most ordinary users, going about a normal day, it genuinely is more restriction than you strictly need. But if you've ever had a specific reason to believe you might be a targeted individual, a journalist covering sensitive material, someone involved in high-stakes legal proceedings, or you simply want the maximum available protection and don't mind a slightly less convenient phone in exchange, it's sitting right there in Settings, under Privacy and Security, near the very bottom of the menu, and it takes about 10 seconds to switch on. Second, stolen device protection, a feature Apple rolled out specifically to deal with a very real, very common, and frankly terrifying crime that exploded in prevalence over the past few years. Someone watching you type your passcode in public, at a bar, a concert, on the subway, then physically stealing your phone moments later and using that passcode to lock you out of your own accounts, change your Apple ID password, remove your cards from Apple Pay, and drain your finances, sometimes within minutes, before you have any chance to respond. Stolen device protection adds a critical extra layer specifically designed to close this exact loophole. When your phone is away from familiar locations, like your home or your regular workplace, sensitive actions, changing your Apple ID password, viewing saved passwords stored in your keychain, turning off Find My, adding a new Face ID or fingerprint, require Face ID or Touch ID. Confirmation with absolutely no passcode fallback option available, meaning a thief who only has your passcode is stuck. And for the most sensitive actions of all, there's a mandatory 1-hour security delay plus a second biometric confirmation required before the change actually goes through. That 1-hour delay might sound like a minor annoyance until